We're going to go ahead and take a look at washers rather than a disk. In other words, we're going to have a region when we revolve it is going to give us a hole in the middle. So for the most part, we're still going to approach it in a very similar way. We're going to still start out by graphing this diagonal line and graphing our parabola, and then we're revolving it around the x-axis. So if we look at our graph, we end up with this here. We are revolving around our x-axis, so that would be going around here. So we're going to take the shaded region, so it's a region between your line and your parabola. We're revolving it around your x-axis. Since our shaded region does not touch our axis of revolution, that means we're going to have a hole in the middle of it when we revolve it. So that means we're going to have to do a washer, which is pi, the integral of your big radius minus your smaller radius, each of them being squared. We have a horizontal axis of revolution, so we know we're dealing with x's. So if we're dealing with x's, our x's have to be dealing with our bounds of how far left and right we're going. So we're starting at 0, going all the way over to 2. So that would be our bounds. Then we have to do our outer radius. So we got to go from our function down to our axis of revolution. That's our bigger radius. So it's basically just your line minus 0. Then your inner radius, which would be the blue, that would be for the hole, the part that's not shaded, which is the bottom of your parabola down to your line. So it would be your parabola minus 0 all squared. So to work this out, I would probably go ahead and FOIL out this, and I'd FOIL out this and distribute through the negative afterwards. Collecting like terms on the inside of the parentheses, we would get this. Now this is pretty easy to integrate, so we just integrate and then evaluate, plugging in your 2 minus what you get when you plug in 0, and well, you know, when you plug in 0, in this case, everything drops, so you don't get anything there, and we get 48 pi over 5. I'm not sure what kind of pi 48, but it says 48 pi. So here, once again, we're going to go ahead and graph this, but notice we're going over our y-axis, which is a vertical axis of revolution. Whenever you're dealing with vertical axis of revolution with washers and discs, you're dealing with y's. So we'll graph this. We're going to have a sideways parabola and a second sideways parabola. The first one is going to be a parabola opening to the right. The second one's going to be a parabola opening to your left. You're looking at what's going on in between these two. Notice you have to be between y equals 1 and y equals 0. So in other words, it's only in between your parabolas right here, up above your x-axis. So if I just kind of zoom in on that region a little bit more to maybe help us out, we just get this shape right here. Notice our shaded region does not touch our axis of revolution, and our axis of revolution here is once again an axis. In this case, it's the y-axis. So my shaded region does not touch my axis of revolution, so I'm going to have a hole when I revolve it. We know we're dealing with y's. Our bounds then, since we're dealing with y's, have to be how far up and down my shaded region goes. Starts at a height of 0, goes up to a height of 1. So then I have to go ahead and look at my shaded region. The bigger radius, which goes from the blue all the way to my axis of revolution. So it's going to be the blue minus 0. My inner radius, the unshaded part, goes from the red all the way to my axis of revolution. So it's going to be the red here, the y squared plus 5, minus 0, my axis of revolution. So then you want to FOIL this out, FOIL out this. You get some ugly stuff, but when you combine together your like terms, it looks like it's pretty then easy to integrate. So you integrate, evaluate, plug in your 1 minus what you get when you plug in 0, and we end up with 16 pi. One more here, we have a vertical axis of revolution, so we know we're dealing with y's. We're going to go ahead and graph this right here, which is a sideways parabola, and your x is equal to 1, which we would know would be a vertical line. So we have our sideways parabola, we have our x-axis, we have our y-axis. We also know that our y-axis is your axis of revolution right here. We are looking for what's between our sideways parabola and our x equals 1, which would be this region right here. So this is our region that we are revolving. Our shaded region does not touch our axis of revolution, so therefore when we revolve it, it's a washer. We're dealing with y, so your bounds are going to be from the lower point of your shaded region, which is -1, to the upper point of your shaded region, which is 1. Then you have to do your bigger radius. That goes from the outside of your region to your axis of revolution, which would be your parabola all the way to 0. So it would be your parabola minus 0. And then your inner region, the whole, which is the unshaded region, which goes from 1 to 0. So 1 minus 0 is 1. Go ahead then and FOIL this out. Still with that minus 1. Combine together any like terms and integrate. By the way, there's a 3y here because your 4 minus 1 is 3, and when you integrate that, you get 3y. Plug in 1 minus what you get when you plug in -1. I would type all this into my calculator at once, leaving the pi out of it. Gives me a fraction, and then I know I end up with pi in my answer. One last one here. We have a parabola, and we have a y equal to 1, and we're going about the x-axis, which is a horizontal axis of revolution, so we know we're dealing with x's. So we end up with this region. If we look at what's between our parabola and our y is equal to 1, it's really this shaded region right here. Since our shaded region does not touch our axis of revolution, we know we're dealing with, we know we're dealing with a washer. If your shaded region does touch your axis of revolution, when you revolve it, it's a solid shape and it would be a disk. We're dealing with x's, so it would be how far left and right your shaded region is, which goes from -2 all the way over to +2. Then you have to do your bigger radius, which goes from your parabola all the way to your axis of revolution. So it's your parabola minus 0, which is just your parabola. Then you got to do your whole, which is the unshaded region, which goes from your line of 1 to your axis of revolution of 0. So it'd be 1 minus 0, which is 1, all squared, because we're dealing with washers. So we can FOIL this out and have that -1, which we know that this part gives us a 24. Then we can go ahead and integrate that, and that's why we end up getting a 24x here. Plug in your 2 minus what you get when you plug in -2. Once again, I would type all this into my calculator at once, just as I see it, and then know I'm going to have a pi hanging out with it.